Good afternoon, everyone. Welcome to this session number 384. And one moment, I need validate that is online. Okay. Okay, nice. The problem is in the chat. The link is in the chat. Oh, but previous to this, I need to check the answer of the other problem. One moment, please. I need to validate. Where is the? Is this? Okay, this is my solution. It is related with the previous problem, but the solution is much more easy. In this case, we have the next. Okay, we have the h, we have the n. The first that is initialize the in degree array to track the number of incoming h for each team. Okay, that is in essential is the idea that I had. You know, validate which nodes don't have any reference itself. Yeah, or no, it's itself is validate or check how many nodes or which nodes doesn't have any reference to reach it. Yeah, in this case, for example, is initialize the degree array to track the number in comment. Okay, initialize this. Now the next that is store the in degree in each team. Okay, here is h in the position 1. Makes sense because at the final it doesn't matter the origin. Yeah, I only need to discard which elements is not a reference for any another, yeah, or anyone. Okay, it is in degree in the position h, champ less 1, champ count 0. And now the next that is transversal and validate where is 0. Yeah, it's the idea. Let me explain very quickly, and after I will try to solve this. It's very fast. It's only for explain this. Yeah, I use this DFS, but it's not necessary. For example, if you have here the 4n it's equal 5. Okay, 4 to 1, 2 to 4, 1 to 2, for example. This number it doesn't matter, yeah, because we only need to know how many nodes don't have how many nodes or which nodes never appear in this position. Yeah, and in essential is that okay, initialize. Oh no. Where is oh, rayos. Okay, let me come back again. Okay, here is that 1 2 3 4 4 1 and it's equal 5, and in this case this value is doesn't matter. We only need to know which nodes appear in the second because it's the destination. Yeah, and initialize this array with 5 slots 0 1 2 3 and 4, and is okay the 2. Okay, 1. Now the next that is the 4 1. Okay, now the next that is 1 1, and in this case the only numbers that have 0 is this. In this case this is the winner. Yeah, this is the idea behind the other problem. Okay, wow, I I solve in a very complex way, but well, It's part of the process. Learn how to do it. Okay, now the next that is this shorter distance after road addition queries 1. And it's a medium problem. And sorry, and the problems have the next description. You are given an integer n and 2D integers array queries. Okay. There are n series numerated from 0 to endless 1. Initially, there is an unidirectional route from city I to city I plus 1 for all 0 it's minor equal well no I it's greater equal 0 and minor than endless 1. Okay, now queries in the index I represent the addition of the new unidirectional route from city. Queries in the index I represent the addition of the new unidirectional route from the city U to city B. After each query, you need to find the length of the shortest path from the city 0 to city endless 1. Okay. Return the array answer where for each I in the range 0 queries that length less 1 answer in the index I is the length of the shortest answer in the index I is the length of the shortest path from city 0 to city endless 1 after processing the first I plus 1 queries. Okay, let me check. We have 5 means that reach the final number is 4 because it's endless 1, and the queries are this. Okay, all the nodes at the beginning are connected, yeah, and for example the first is 2 and 4. 2 is connected with the 4, and the answer is to reach the since this until this is 3. 1 2 3. Okay, now the next that is 0 is connected with 2. How many jumps I need to do for reach the final? In this case is 1 and 2. Okay, now the next that is 0 and 4. How many? In this case is only 1. Yeah, this is the idea. Okay, let me copy this. I think that this is a graph problem. Okay, and well, okay, and okay, at the beginning we have the nodes connected in this way. And it's equal 5. And for the first is apply this. Okay, let me check before. Let me check the constraints. And the minimum size is 3 and the maximum is 500. And the query's length at least have one element, and maximum I have the 500. The queries the value, no, the length of every array is with 2, yeah, because it's origin and destination. Now the values are between 0 and n. Okay, and queries in index queries in the index I1 less queries in the index 0 is greater than 1. Okay, there are no repeat rows among the queries. Okay, now having this, the first that is this point, we need to connect this with the 4. I am thinking, let me change the color for this. This is the new, this is the query of this. I am thinking that have a short path to reach every short path. No, I was thinking that if I know that the short path when you reach the number 2 is this step, yeah, you don't need continue with the process of performing the function. But I think that I am trying to improve a function that before to create it. Let me try to resolve first in the normal way. In this case, okay, we have the connection between this and this, and now I need to figure out what is the short path. I think that I need to do this to this, now this to this, and now this have two paths. The first is for this side and then other is for this. I think that if I reach this, I know that is 3. Yeah, this is the minimum, and the other is with this, and when it's greater, well, even I can continue, but when it's greater I can stop it. Don't make sense continue because it's not the answer. Okay, now we have this. The next that is between 2 the 0 and 2 means that I can go in this direction, 1 2 3, or 1 2 3 4, but 4 is greater, still in 3, and the other is 1 2 3, still in 3, and the other is 1 and 2. Well, the minimum is 2. Yeah, for example, here is connected with the 4, and if I move in this direction, yeah, I think that I need to do all the operation, because I was thinking that what happened if I remove this connection. And I move this was removed, means that I only have one path or one way to reach the 4, that is this. But what happened when appear, for example, the 1 is connected with the 2? No, it's with this. Have this connection to reach the 4, and if I start here, this is this. Yeah, I am trying to avoid this operation to go in this path, because I know that the length at the beginning is 5. 1, 2, 3. No, it's 4. It's 4. Yeah, I know that is this is the way. But what happened, for example, if I have like this? Oh, is this? Sorry, no. Is this this? Mm-hmm. Uh-huh. If I start here, is we have only one direction, that we have one. Now is get the short path. In this case, this is 1, 2. Now is come back, come back. Here is 2, 3. The minimum is 2. Yeah, for example, if this have 5 and I change this for no. Change this for this, and I start here. Yeah, I go to the next. It's only part. Now the next that is this. No, is this. We have 2. The next that is this, 3 and 4. We have 4. Now come back to this. Don't have anyone. Come back to this. Now is here. 1, 2, 3, 4, 5. But 5 is greater. Come back to this. Come back to this. And come back to this. Now here is 1, 2, 3, 4. I don't know, because if, for example, here appear many news validation like this, yeah, don't make sense continue with this. Maybe my idea is that have a record where every time that I reach this node, discover what is the distance, the short distance to reach the final. For example, at the beginning, the number of jumps, the minimum number to jump, no, the minimum number of jumps to reach the number 5, well, no, the number 4, sorry, is that 1, 2, 3, and 4. Even at the beginning, we know that this is 3, this is 2, this is 1, and, well, obviously this is 0, yeah? And now the next that is, and only modify these values, yeah? Now, the next that is 2 with 4. Is this with this. Okay, the previous way to starting here, the previous number to reach the 4 starting here is 2, but now is 1. Okay, this is updated and now is 1. Okay, but how I can get this 1, 2, and 3. Oh, I think that is the total less the difference. In this case, the difference between 2 and 1 is 3. 1, 2, 3. Okay, okay. Until now, makes sense, yeah? 3. Now the next step is 0, 2. Okay, the previous was the 4 to reach this. Okay, now I can create a bridge between the 0 and the 2. Now, now here, I think that if the maximum or the previous minimum was 4 or is 4, now we have another path. In this case is the jump to the 2, and now is but how I update this? It's only reduced because it's an static numbers. Yeah, in this case, for example, 0 to 2, the difference between both numbers is 2. Yeah, this change to 2, and even, yeah, 1 and 2. Okay, the size, the next is done. Now the next that is, this is done. Now the next that is 0 to 4. Okay, we can create the bridge. Okay, now is the difference between this and this is 4. 0 and 4. 0 and 4. Now the minimum is 2. Sorry, and I need to count. In this case, I reach the 4 directly, is 1. Now this is updated to 1, and this is the minimum. Yeah, okay. Let me try to do again, but now with 5. Yeah, and in this case the last is 1 to 4. Okay, and now here we need add one result. Okay, the first is that okay, this is 4, no, 1 2 3 4 5 5 4 0. This is the numbers. Okay, now is between 2 and 4. Okay, I can create a connection. I don't need to start here because I know that for reach this number the minimum of jumps is 3. I don't need calculate this because I know. Yeah, it's only add. Okay, 3 and sorry, no, this is wrong. Is here. Yeah, in this case is 3 is the minimum. Here this should be updated. Is 2 to the 4. We have 3 plus 1. Now the 4 go to the minimum is 1. Yeah, even I don't need to reach the final. It's only, okay, this plus this is 4. Okay, in this case 1 2 3 and 4. Is this plus this. In this case, this is 1, 2. No, is this less this. We are saying that in this case, for reach the 4, the short path is 1, 2, 3. No. This number is for the target, for reach the target. In this case, for example, is this plus 1. In this case, in 4, 1, 2, 1, 2. I think that this is reduced is 3 less 1. In this case is 2. And for reach the final is this less the difference between 3 less 2, it's equal 1. 5 is 4. Yeah, in this case is 1, 2, 3 and 4. The first is 4. Okay, now the next that is 0, 2, 0, 2, 2. This. Okay, now reach this. I know that for reach the final take 2. Yeah, and what is the formula here? Is 3 the previous 5 less the new that is 2. In this case is 3, and now we have 3 less 5 less 2. This case is 3. Okay, it's 3. It's equal 3 less 3. It's equal 0. But no. 2, 3. Oh no. Okay, I think that I am confusing the formula. Let me try again. I think that it's a good approach because in this way you avoid to transversal all the time the graph, yeah, the direct graph. But let me check again. I am losing the thread in my mind. The first that is put how many. What is the short path? The short path in this case is 5, 4, 3, 2, 1, and obviously the number 0. Yeah. Sorry, I am checking the Twitch. Okay, nice. Okay, and now this is 6, and this is the short path. Now the first that is the 2 and 4, 2 here, and reach the 4. Yeah, all the time this should be updated to this, and this is updated. Okay, but let me in this case the 2 have the connection with the 4, and now is the difference between the 3 less 1 it's equal to, okay, this here. And now the difference between this 3 less 1 it's equal to, and now is the difference between 3 and 2 it's equal 1. Yeah, this is the difference. And this difference is reduced in this. This is 5 less diff. Diff in this case is 5 less 1 it's equal 4. Okay, this case the first time is 4. Got it. Now the next is 0 to 2. This to this. Yeah. And now for each the why I don't update this? I need to update this value too. Now is 2. 1, 2, 3. Now is 2 because it's starting here is 1, 2. And now is 0 to 2 is this. Now this is no, it's here. Here is the current value less this 2 is current value less 2 it's equal to, and the difference between 4 less 2 it's equal to. Okay, now is 4 4 less 2 it's equal to. Now this is updated to 2, and yeah, it's updated to only 2. Okay, the next is 0 to 4. Okay. In this case is again these 2 less 1 it's equal 1. 2 less 1 it's equal 1. 2 less 1 it's equal 1. The difference is 1. I think that is always the same number, but in this case is 4 less 1 it's equal 1. This is updated to 1. But here is wrong, because here 1, 2, 3, 4, 5. But now I am saying that I can reach the 5 in one jump, but it's not true. Okay, I think that in one moment I confused the steps. This case the first time is 5. Now when this is updated, the difference between 4 and 2 is 2. I think that is less 1 because the difference between this and this is 2. 4 less 2 is equal to, but we need to count this because plus 1 in this case is 3. We are saying that when you reach this, the shortest path is 3. 1, 2, no. What is happening here? Okay, I need to do again. Okay, the first that is the first is between 5, 1, 2, 3, 4, 5, 2, 4, 3, 2, 1 to reach the final is 1. And now is 2 reach the 4. Yeah, in this case the short path was 3, but now but the short path to reach this to this is 3. 1, 2, 3. But now is start this is this plus 1. Is this plus 1 because in this case this is the number of how many jumps I need to reach. I need to reach the final number. In this case the 5 is basically go to this, and what is the value? The value is 1. Okay, is 1. Is the destination plus 1. In this case this is updated up to, and now what is the difference between the previous less the current? In this case the previous was 3 less 2, it's equal 1. I need to reduce this in 1. Okay, now the next is between 0 and 2. The 0 and 2. Okay, I need to take this plus 1. Yeah, basically it's this 3 destination plus 1. Now is here, sorry, and now is destination that is 2 plus, even do 2 plus 1, it's equal, no, here 2 plus 1, it's equal 3, and update this value. I think that where is the 0 is not necessarily updated, it's only ignored. Yeah, and now we know that we need 3 jumps to reach the final. 1, 2, 3. And the next that is between 0 and 4. Okay, we have and 4. Now is this plus 1. Okay, in this case we are saying that is is 2, and is the 0 is omit the step for update again the index 0. In this case the minimum is 0. No, it's 2, sorry. 1 and 2. Now the next that is the next in the list is 1 and 4. 1 and 1 and 4. Okay. Now here is what is the number is 1 plus 1 is 2. Okay, this is updated for 2, and now is the previous 4 less 2, it's equal to, and I don't know, I hate the notification. Sorry, previous to current. The previous is 4 less 2, it's equal to. Now this is the value here that we are saying that in 2 steps I reach the final 1 and 2. Yeah, I think that makes sense. I think that it's a good approach. I need only to calculus destination plus 1 and previous to current. It's the Slack. Okay, now for following this algorithm, the first that is I need one array of the size n, have in every slot the minimum number to reach the final. In this case, at the beginning is basically if the size is 5, is 5, 4, 3, 2, 1, and 0. Yeah, and next to is only updated or apply this for the current in the position 2. Now the minimum path for reach the final is the destination, that in this case is the 4 plus 1. The 4 contains 1, 1 plus 1 is 2, and now it's updated. Yeah, I think that it's enough with this. What is the, oh, well, in this case integer paths, it's equal new int, this case is n. Now I need a 4, integer I, it's equal 0, meanwhile I it's minor that n, I plus plus. Now the next is yeah, here in the position paths, in the position I, it's equal n less I. Because n is 5, I need 5 jumps. 1, 2, 3, 4, 5. No, in this case is 6. For this, that is 6. Is 1, 2, 3. It's less 1. Less 1. And now transversal de 4 integer q queries, in queries integer origin, it's equal q in the position 0, and target. I don't like the word destination. Target is the 1, and now the first that is calculus the new integer new calculus. I think. Is target, no, is paths in the position target plus 1. And I need to update the paths in the position origin. It's equal new calculus, but before this I need to check the previous to the current. Integer new 0 calculus, it's equal this less this. And now it's updated. And the next step is ask if the origin is different to 0. Yeah, I need to apply the paths in the 0. It's equal new 0 calculus. No. New calculus. The new calculus is this d plus 1. D in the origin. The origin less new calculus. For example, here is 2 plus 1. Okay, the first is 2 to 4. 2 to 4. Now this is updated to 2. And now is the previous that is 5. No, here is wrong, right? How I update this to 4? Okay. Is less this number. Yeah, is this? And we need to. I need the result. It's equal new int with n integer. No, this is not necessary. Return array answer where each I. No, this is the size of query, no n. And here, integer j it's equal 0. And now here is result in the position j plus plus, it's equal this. Now return result. Why 1? Why 1? This is wrong. This should be the previous origin. No. But in the origin, let's this is minus equal. Okay, well, at least the first works. Now the second, what is happening with the second? 0, go to the 3. But in this case, for example, never appear. Let me check this. Sorry, very fast this. We have 0 to 1, 1 to 2, 2, 0, what? 1, 2, 3, and that's it. Yeah, now the 1, 2, 3, 2, 1, and 0. Okay. Now we have the first that is 0 to 3. In this case is is 1 and 1. But I am returning 2. Why? In this case is 0 plus 1 is 1. In this okay, it's because this is 2. Is diff destination less 1. In this case is 0 less 1 is 1. Now this is 3 less 1 it's equal to. I think that where happen these cases, where is the 0 and reach the final, I need ignore this formula and put directly what is the short path. In this case is 1. Yeah, because no. For example, when is this is okay, 0 plus 1 is 1, and now the difference between 3 less 1 it's equal to 1 and 2. Okay. Now before this I need validate if the origin it's equal 0 and target it's equal n less 1 origin paths in the index 0 it's equal 1. Yeah, and continue. And even here I can put an this for ignore the next. Yeah, basically it's it's 0, 0, 0, 0. Well, no, the position 0 have 1, that is the minimum. You can continue 0 and 0. Sure, it's because this I need to apply this operation. Yeah, basically where I add this, I know that the next should be have the same. Mm-hmm. One, two, three. Okay, well, I think that it's enough for this transmission, but tomorrow I will continue with that. I feel that I am close to the solution, but well, thanks for following this transmission, and I hope to see you in the next. Bye bye.